now will be very pleased to introduce our speaker for this evening. And our speaker is Matt Rule, who is the CEO of Toka.io, and which is and he's going to talk to us about various aspects of low code. So over to you, Matt.
Thank you, Simon. Pleasure to be invited to do this. Right, I will do click and share. Drum roll. So I'll go in that way. Right. So can everybody see my screen? I'll look to Simon to give me a thumbs up.
Yes.
Right. Good.
Yes, that's good.
Right. Thanks very much. Right, I'm running 2 laptops, so I will be weirdly looking to the side. I hope that doesn't put anybody off. Like I say, thank you very much for today. Simon, you gave me quite a wide remit, and as I went into this, I realised I'd bitten off way too much. So I've probably got about 2 hours worth of stuff, and you've told me 45 minutes. So I'll either speak about 2.7 times faster, or we'll have to just cut a few corners. But so I'm Matt Rule, a founder and CEO at Toka. I started this journey sometime around about 2016, 2017. Toka's been running since 2018 officially, and we're about 30 people. We're based in Reading, predominantly in the UK. We've got a small outpost in Canada. And we do low code for businesses, for large businesses and enterprises. We've had a bit of an interesting journey along the way, and where we focused, and the low code market, how that's defined and developed. But really for today, I wanted to try and undo everything and tell everybody that low code is nothing new, and probably spectacularly backfire on how I debunk it. But there is a growing prominence in this area at the moment, and I think if we have a look at the history and sort of learn from the history and see, well, what was being done right as far back as the 80s and what that looked like, and just have a quick browse through that. I will start my timer, otherwise I will be 2 hours, and I'll just see the numbers drop off. What we won't really touch on is AI, LLMs. Of course, they are interacting with the sort of tech that we're doing, but that's not what we're here to talk about. This isn't AI per se. We probably won't touch politics or religion either. But what we will do is we'll start to just pull apart the low-code systems and just see what are the main components for these. And I'm hoping that gives the technical ilk on this call a bit of a real understanding of, what is a low-code platform and where can I use it? And we'll touch on that at the end with the applications. So I'll do my best to squeeze this all in. Looking to the side. So obviously, like I say, walk through brief history. Low code, the term was coined by Forrester, as far as I can see, as early as 2014. I can't see reference to it anywhere else. And I think it's one of those things where it's deliberately divisive to say it's not high code. And it's starting to sort of draw a line to say there are these high code systems, and it's probably saying that this high code, it's complex and they're slow to deliver, and that low code somehow a lot quicker and a lot more simple, but maybe there's a compromise on customization or, where it's applied in what markets. I think that's roughly why they're doing it. Note that we sell low code as Toka, but we're a high code company. So I feel like I can probably answer this from both sides of the fence, and hoping there's some questions later from any developers on the call. So it is an important term. It is much like, the joke that cloud is just somebody else's server running in a data center somewhere. Yet the non-technical ilk in our industry tend to think of cloud as this just magical thing and its infinite resources. And I think if we can, break that down, that's really going to help. When we're talking about low code today, we're talking about how it's an application for distributed systems. And when we look at the history, we're probably going to look, and a lot of that's monolithic. But we'll jump into that. So we will start at the beginning. I'm conscious we've got 45 minutes, so we'll start at 1645. This guy was not content with living in 1645. I think the guy thought he was from the 1970s something, and he devised really the first computational, the need meets automation, automata, whatever, and built this calculator that that could do obviously basic things, and the requirement came from business. It was for tax. And this is kind of important because this interaction between what businesses need and what we're doing here today with computing. It's this, I guess, is automata before that, but this starts that conversation in my eyes. And so we'll just start really quickly on market dynamics, and we will get into something that's a bit more technical. We might even look a bit at a bit of a live demo. So there's a guy called Geoffrey A. Moore who wrote Crossing the Chasm, and I've read the book front to back twice, and it took me about 5 years to really start understanding what the guy was talking about. That probably says a lot about me, but what's important about this is this category here that says innovators, and you can look at those people as white coats. And when anything starts out in computing and in technology, what we know is it starts with mainframes in rooms run by white coats, run by experts, deep technologists who love complex technology. And what they do is they obviously look for funding and they look for opportunities, or vice versa. Funding and opportunities might come from military, might come from large businesses, and they might be looking for a competitive edge for some reason. And this dance starts. So you've got very early computers coming out in the 50s and the 60s, meeting needs of businesses. And those businesses, what they would have been spending £10 million or whatever the number is. And we've all seen the hard drive coming out the back of the lorry, and it stores just a meg or two. And, people were happy with that at the time, and that's all there was. But the point here is that starts this dance, and that dance is talking with businesses and saying, we've got this technology, what could you do with it? And the business takes that, the early adopters, the innovators take that, they start to use it and apply it to business, and then they start to get needy. And so the other curve that's important here that kind of drives through, so you're looking at this on time, we've all probably seen both of these. I'm hoping on the call. Certainly, I would imagine the Gartner hype circle is more famous. But we start to see this hype, this demand, this excitement that starts really accelerating how early technology starts to evolve and develop, and matching those demands into business. And less important here is the trough of disillusionment, which we've all witnessed and seen in many different threads. Even the internet, as I see one of the talks coming up in the future. Ultimately, when that was early 2000s or whatever, we all know what that is. But where we then start to kind of get into the mainstreams, that plateau of productivity, and if you overlap that into the innovation adoption cycle, arguably that's then where you've got the early majority, late majority, and you start getting the bigger businesses and the mainstream businesses coming on side. But something's happened with the technology offering to get into that mainstream and to start to get into that plateau and to get further down the line. The technology companies have done something. So they've moved from being white coats and experts and offering out this visionary technology and, disrupt your competition and all of this good stuff. And they've started to, there's external pressures on them. And I'm one of those companies. And by the way, this effect happens really quickly. Businesses start to demand instantly, is it secure? Is it maintainable? It should be 5 nines reliable available all the time, and is it scalable, and where's your documentation? All of these things, we need it, and we need it now. And it's an intense pressure that you feel. So what we're arguing here is that we've offered a piece of technology which is, it's got that inkling of viability in the market, and that the earliest businesses have picked it up, and they just start getting really, really needy. And they're not getting needy back on just one company. What then happens is other technology companies see that there's an opportunity, and they start to multiply. And so there's multiple computing companies, or there's multiple, whatever it is, accounting, spreadsheet, database firms. They see that opportunity, and they see that there's a bit of a gap. And this is probably teaching grandma to suck eggs to some people, but let's just do this exercise because it just brings us all on that same page. And so you get this interaction, you get this dance, and it drives down. So if we started at high risk, high cost, we're selling to entrepreneurs, we're entrepreneurs, everything's Wild West. What we're getting is, as the businesses are now starting this demand, the technology companies need to step into line and need to behave. And the cost and everything about that technology needs to round off, soften off, and become a lot more available. I wanted to touch on this because it's the underpinning driver for what we're doing today and why the low-code market exists and where it's come from. Arguably, low-code is nothing but the story of computing. There's nothing to see here. It is just, it's a continuum. And I think that's the point that we just need to take away here. The next part that I wanted to touch on, so we know that early technology goes out, it's complex, it becomes simple, and that there's an interaction between your customers and the technology providers that causes that. That's quite exciting. What I then wanted to do is go, well, I love looking back at history, and I'm 43, and I probably started programming sometime around 1998, maybe 1989 or something. Clearly not that sophisticated. And it would have been basic. A big shout out. But what I do remember back when I was a kid is a piece of technology that was 2 years old was almost, really old, or if it was 3 years old, I've never heard of it. And so it was quite interesting to do this bit of research. Let me just keep an eye on the time because we've got some other stuff to talk about. So what I wanted to do is look at 3 ingredients in history. And in order, what the first one was is to look for what's the earliest RAD platform, rapid application development. It promotes prototyping, it promotes drag and drop, it promotes frameworks, simplified code, actually getting that prototype built and getting that out to market. And the earliest thing that I could find was Smalltalk, which I've never played around with. And I've got here that's Xerox. I always thought it was Apple, but we know that those two things start to become synonymous as you move through the 80s. So Smalltalk 76, to be specific, offered all these different features. And I couldn't quite get the details, but I believe on the Xerox, and maybe there'll be something in the chat, the actual machine it was running on was not was 8-bit, not 16-bit at that time as well, which was quite mind-boggling. The first quite sophisticated then, on the ingredients. So we've got these RAD platforms. The next thing that I was looking for was visual programming. So when's the earliest visual programming systems? And really they start to congregate around 1986. And predominantly they're focused on Apple because Apple had the most advanced GUI, a mass market GUI system at the time, even though the machines cost arguably whatever it was, I think it's £5,000 in today's money, up to £8,000. So they weren't very accessible. But and so hence, the early sort of GUI systems were prevalent on that platform. So the one that jumps out at me is Prograph. And just note, that actually Prograph is not around today, and it from what I can see wasn't a great success. That unlike LabVIEW and unlike FileMaker, which we'll touch on shortly, we'll go into this in a little bit more, and we'll pull out some of the features. HyperCard, I didn't hear of that until probably the late 90s, 2000s. But I don't know why. There was obviously no internet to talk about that. I guess some people would quaff at that and think, well, but you'd have to, I'm sure, been Apple focused or Apple born or been fortunate enough to have an Apple system either in your business or whatever it is. But I hadn't come across that. I would have been 6 as well, so maybe that's an issue. DBase and DBase 4. The reason I've called these out is you're now looking at desktop databases. So we're starting to bring together the ingredients of a RAD, concepts of visual programming, and desktop databases. So not a huge, great big centralized database or something like that on a mainframe, but something that's a bit more, on the desktop. You can load data into it, you can query it, and you can organize a small business around it. When I was pulling this together, I contacted the septuagenarians in my life to kind of try to get a feel and a view. And one of those guys is my own father, who was a big DBase 4 user in a large, it was an appliance manufacturer that I won't name, but a very good appliance, white goods manufacturer. And he was programming those systems back then. I think he said DBase 4 was full of bugs and didn't work, but what that means in our talk here. But where we start to see, I've included Amiga, by the way, because that was my era. What we then start to see in 92 is Windows 3.1 comes out. Instantly, we've got Microsoft Access. Microsoft Access to me is the definitive start of a low-code type technology. Its issue is it produced monolithic, or arguably mostly monolithic applications. There's no such thing as web-based applications back then. I guess some, entrepreneurial people might have made it a bit more distributed, but it wasn't going to be rolled out widely across a business, unlike where I've included Oracle and Oracle Forms, for instance. And Oracle Forms 4 is the first version of Forms where it's got that GUI interface, as far as I can see, and that's lending itself to businesses being able to tailor technology for their own purposes. I've included Windows 95 because that's really at the start of the big ramp of GUI systems, and then just some other ones to include here. We're going to go and have a look at the early 80s stuff in a minute, but some of the other systems really to include, ultimately Scratch. Strangely, when you look at where Smalltalk were focused back in the day, they were focused in education. And I don't know if there's a thread here, and I can't find too much research, but again, good one for the discussion is some of these early tools seem to be pushed into that educational angle. Is that because, I don't know, with the C programs at the time that would stick their nose up at these technologies that appeared to be overly simplified? Scratch was interesting because clearly MIT Media Lab wanted to get that experiment in how they could build visual programming language. I'd argue Scratch is more low code than a pure visual programming language. The start of OutSystems and Appian, they're big competitors to me. Fantastic platforms, fantastic systems, and it's just worth noting that FileMaker's made it all the way through to present day. The last thing, just a note on here, and we'll go into it a bit more, is LabVIEW, and then Hewlett-Packard with HPV, which is now Keysight. They both pioneered more into labs, and actually that's where I started. And I think that's where I got the idea in the bug for Toka, was from using HPV or Agilent V when I was there. And you've got us in Power, and I can tell you there's a lot more platforms today. So I'll go through this quite quickly because I want to get into the concepts. I can't see Q&A as well, so I'd have to rely on Simon or somebody to so James has made a comment, but I'll come back to those, Simon. I don't know if you shout out if anybody's got any comments midway through.
Yes, I'll keep an eye on the Q&A, and we'll batch them up at the end. But if anyone has a question, please do put it in the Q&A as we go along.
Thank you. So real quick, this is a visual programming language, and this is right back in released in 86, worked on from 1983. we can see this is running in Apple. Concept is dead simple. This was a data flow language. Different shapes promote different types of semantics effectively. You're connecting lines and wires, as you can see on screen, and it's top to bottom, and that's how the flow works. It's much like a flow chart. What's very apparent as soon as you start doing any of this stuff is hello world, super simple. Something here where you've got 3 different types of sort starts to get into that spaghetti code. The feedback that I could see, and I've got Noel, some of these images have come from, there's a Medium article, not very much about on the internet about this, but a guy called Noel Rappin wrote a really good article. I think he picked it up in the mid-90s. He absolutely loved the language because it promoted really good coding and programming concepts. If we jump through, the early platform had this concept of validation, and you could get into relatively decent amounts of complexity. So Noel, if we just go back ever so slightly, Noel had also pointed out that the debugging environment within the system is absolutely phenomenal, is brilliant. Note that this is a monolithic platform as well. So it's not distributed. It's not having to worry about transfer of data objects and the size of the data and all of that wasn't necessarily a problem. So it was a great start into just a visual programming approach. One that was extremely successful from 1986 is LabVIEW. Now, I was never a big LabVIEW user. Like I say, I use the main competitor to that, which is HP and Agilent V. They're very, very similar. And so what you've got here is I've taken an early screenshot. To be honest, nothing's changed. It's just become color. Is this concept of a data flow. So you're taking values, you might take a signal in from a scientific instrument, and you're connecting that into, you might take the mean number, or you might decode a stream of bits or whatever that's coming into your system. And then you might start to then do some pre-filtering and data analysis, or you might manipulate that, or you might call out to different external platforms with that data. The flip side then, so you've got 2 sides to LabVIEW, is you've got this data flow area. And then if we turn the card round, you've got this UI that you design, and you connect those 2 things together. And so you can build really, really nice lab platforms that can pull all of your instruments and control all of your, if anybody knows what, signal analyzers and vector signal analyzers and power supplies and all these things, you can control them, get the data from them, and then build that single pane of glass and be able to control the systems, but also get the scientific data out. And they're just so enjoyable to use. They're absolutely fantastic. They also allow you to code as well. So if you've got something like an algorithm, you've got something you want to do, you don't have to put it all in visual programming. And we've in Toka, we've also implemented that approach. We've borrowed heavily from those early concepts. This is a shot of Agilent V just to complete the picture. Now Keysight, very much the same. Data flow down here, and then flip it round. That's then where you build your UI and you connect your UI to your data flow at the back end. It's as simple as that. You can compile these applications and distribute them as well. That's really powerful. And it's a complex area, particularly within distributed low-code systems today. These are still monolithic. And what I mean by that is these are looking to run on a laptop that I'm talking to you from now. They're not looking to serve up applications necessarily across the internet, multi-tenanted, having to deal with all the security and all those things. Finally, I should keep up with my notes. So I had to include this. It's HyperCard. I couldn't really find a great screenshot. You'll notice I managed to get BCS Oxford and get a button dragged into the screen running on an old Mac emulator, but I haven't got time to kind of give you guys a live walkthrough. Some have argued that this is the precursor to sort of web and HTML. I guess I'll go along with history if that's what people say. I think it's arguably a lot more powerful than the early HTML platforms. But it's a great example of this it's a combination really of a RAD and a visual programming language. It's not quite visual programming. there's a lot of heavy amount of Apple script and what have you in there. Really good and powerful drag and drop UI design, a lot of pre-built components so you can move really quickly. And it was, some people have coined this term card based. You're building really what today would be different web pages, different web page screens that you can navigate through. And you can connect those pages together and you can kind of run code in the background. And in our world, you'd run workflows. So if we just now take these ingredients of history, and I have focused mostly on the 80s, the 90s and through to today, it's just a gradual continuum. So what we've noticed is we looked at a lot of the early systems, visual programming and RAD, pull those together. They were quite powerful. They used gradual typing, and I'll explain what I mean by that for the developers all on the call will know what that is. So within programming, we can have a strong type language where we have to define what our types are. Is it string? Is it, what type of object is it? What are we expecting? What are we dealing with? And if you look at something like Python, and particularly BASIC, arguably they're gradual typing, or they can behave in a duck type language. And what that means is you can handle those different objects. You don't have to explicitly define them. It does cause problems because explicitly defining what you're handling, is it a string? If we take a Boolean, is it true or false? And do I want that to be represented as a 0 or 1? Or do I want the text true or false? And you start to trip up when you start to program these things. And so you kind of, in our world, you need some balance and you need somewhere in the middle. You could handle tables and databases, and these things were starting to come together, albeit the databases weren't very powerful. Lots of them promoted script. Script is important and code is important. If we're doing low code, it just means low code. It means code is fine. Don't try to build spaghetti code as we saw with Prograph, when actually you could just write some lines of code. We can read it. We're not, it doesn't have to be written in a complex, advanced programming language. Pick something like Python. It's really powerful. And, generally as technologists, we can pick that up nice and quick without having to do a lot of training. Drag and drop components, of course, we saw that in the early stuff. Whether it's interesting for this call, obviously the packaging distributions, I'm just kind of skipping over that. We'll come on to it. But the early years were all dominated by Apple. They weren't very prolific. They didn't really go anywhere per se. There are some long stayers, FileMaker, LabVIEW, that have survived right through to present day. But really, the traction actually happened in the 90s. Once we started to get GUIs and UI, I started to drive this and started to build a lot of these monolithic low-code platforms as you would recognize them today started to appear. But as soon as we then started to switch to this era now where we expect our applications to run within a web browser and be web-based, it kind of halted some of those low-code platforms and they've had to make a bit of a shift. The argument here is that, and really by doing this research, I've kind of taken a moment of reflection, is and actually we'll skip forward and we'll go into this point a little bit. So if we summarize what general market requirements are, and we pick these out early on, this is what businesses force upon you, thankfully. You've got to keep up. If we add to today's world, I'll use some old language, distributed client server, but they're all web-based applications. And the web-based applications run code, script within the browser. They then run code and script, arguably in a couple of areas within the backend as well, even inside the database in certain modern database technologies. And so we have quite a few areas where we're executing code, exchanging probably quite large data and data objects, all to kind of build these applications that we build for our customers, and it's quite complicated. We've then got the lurking worry and pain of security and trying to make sure that we're throwing all this data around the internet. How do we keep that secure, and also how do we keep these systems online and running? And then how do we do all of that low code? So by switching from monolithic design and drag and drop and all of that and going to distributed, it's just a factor, multitudes more complex to do. And to kind of, I thought this was going to be easier when I started Toka, for instance, and it wasn't. But I can't remember the US president who said we'll go to the moon because it's hard. You know, I started this because I thought it'd be easy, and it wasn't. But it's exciting. You've also got legacy technology, so the systems now of the 90s and the early 2000s are now legacy. You need to be able to talk to them if you're going to build a business focused low-code platform. So let's get into the design. Probably took a bit longer on that than I wanted. So it's got to be distributed with an exclamation mark. We need some visual programming. We need structured flows. We need to be able to write code for the system and extend it and add code components. We need to be able to handle data, database storage, and do some relational data stuff as well. Drag and drop, that's easy, great. We need to be able to allow high customization as well for the system. People don't just want to be stuck with the same old looking thing. Between me and my competition and the companies today, there's varying degrees of customization that can be carried out, and that kind of in exchange for the complexity of the platform. Rapid application development is back. Don't be afraid to use that term. It's absolutely fantastic concepts, and it can fit in with effectively agile delivery, which is, you know, what we're doing. We obviously now need to be able to build it, manage versions, deploy it. Some of that's got a bit more complex today. And then with us, particularly, not all of the low-code platforms, we recognize the need to be able to support legacy and to be able to integrate into a legacy platform. That might mean it doesn't have APIs, it might mean it only has GUIs, but it's really important. So what I'm going to do now, quick breather, is just go into what the concepts are, what the different blocks are that will make up the architecture. So what we're going to do is we're going to end up with a nice big full screen of a load of boxes. We'll go vaguely technical into this stuff. It's a shame we're not all in the room and I can't see your faces as you nod off and disappear. But so what we started with is two things. We started in automation, which means back-end logic, moving data between systems. And we started in arguably this project around about 2016. And we started with this thing RPA, which most of you all know what that is, but robotic process automation. So being able to control a system with a GUI. We always looked at it as GUI and API, and the two things should be synonymous because you're just talking to a system. We had a very early on data action. So can you extract the data and do something with it and then move it into your next system? And then also always have basic programming features, because there's no point, and we learned our lesson within the first few months of our existence, is do not be purist with this. You're there, it's a tool. You know, you look back at Mr. Pascal, you know, he needed a tool to do his job. It's not about purism. It's not about saying to people, you must use visual programming and don't touch anything else. It's got to be a bit of a mix. And so you need programming in there. And then data storage, basic data storage. And what we started with here was just a don't care database, general structure, just blobs of data. Nothing really that sophisticated. So the next thing that we needed, so if we could make two systems talk with each other, and there was a great market for that, and there's a number of RPA companies that did really well from it, is no business process starts without a person. Not yet. I said we wouldn't talk about AI and all of these things, but there's no businesses that are running. There's always a kick-off point. And what I mean by that is if we're coming into a business and we're going to digitize and we're going to like put technology and compete some sort of computational capability in there, then there's no point in us being on the back foot, being given data from an old website, an old web page, which is kind of semi-structured, and we're spending all of our time trying to understand the structure of the data we've been given, or a user writes their answers into a PDF, and then we've got to somehow OCR and extract that, and we don't have control of it. And so what we started to say to customers is, well, why don't you drag and drop and build apps and get rid of that old Word document? We engaged with the police early on, and they had an old Word doc form for firearms licenses and things like that. But all that was happening is you're digitally kind of writing into this Word document, and then it needs to be read by a person and then entered into a database, and decisions need to be made over it. We'll just get it into the databases and do that stuff early on. So we argue you need apps. The next thing that we did, quick crafty look at the time. I cannot believe I'll do any sort of demo. We might switch back and forward and have a look at the system in a minute. The next thing that we did was to say, we can't physically now keep up with that demand coming in from the market of all the different things that they want. And so at the core of our platform, we needed to create this core dev kit and this kernel of capability, and make that dev kit really easy to use and allow people using high code be able to extend the platform. So it's a low code system, but it can be extended and it can meet the demands of what's coming into the market. Just to note there, as we then and within our low code platform, as then we brought in this development kit in the center, that then meant that development kit, because everything we're offering is web based and it has to be distributed and all of this stuff. And our platform is web based itself. There's no GUI monolithic application to enter into it. You administer and work with it in a quite an advanced web application. We needed back-end build components to build the C# and compile DLLs and build and build the React websites as well and get them deployed. So there was lots of automation and logic that needed to happen at the back end. I've been able to pull down, if those of you that are .NET will know about NuGet, and being able to pull down different packages dynamically. That all had to be built in at the core, and it was a lot more complicated than building a monolithic application. We could have done that a lot quicker and a lot easier. So we've had to, I've actually skipped over something that's quite important. So in automation, within our system, we have a visual programming, and I think what I'll do right now is jump into our platform, and I'll rely on the test that somebody will shout up and tell me we can't see what you're talking about. We're now looking at Toka, and we've just jumped into a low-code platform. By the way, this isn't a sales pitch for Toka. OutSystems is fantastic. Appian's fantastic. There's lots of systems out there you can go and look at, and you're probably using. This happens to be our system. I have no hang-ups on our competition. I think they're fantastic. So within our platform, to be able to process and automate and build applications, we've got a number of different execution engines, which are quite complex. But what you'll see here is a visual programming language. So we've got basic functions where we can build a business process. We've got a little action in here that will run some stuff. It will get some data. Got lots of stuff that we can bring into this screen and lots of different things that we can process, but it's quite simple. And we've done that deliberately. What we've done is we've taken the part of visual programming, which is actually quite useful for data flow. And then when you actually need to build some steps, we can edit this step and we can come into and in this world, we're doing GUI control. Not everything is GUI control, but clearly for demo, it's a lot more interesting looking at a GUI than some sort of API stuff. And we've got a platform here where we can control this. This is actually a Linux machine running in Docker, and we can actually make it automatically open up a browser, extract some data. What it's actually done, if I go into interactive mode, it's actually just extracted some rows of data for us to use. And it's got a debug environment, and it's telling us, well, I just opened the browser and that went fine. And I've just extracted some data, and here's 100 rows of data for you. And it's just handled all of that in this browser. And by the way, this machine's running in the middle of Germany. So however 100 miles away that is, a few thousand miles away, and it just runs seamlessly. And so if this was a monolithic application all running on the desktop, it'd be a lot easier to build. But as soon as you come into this distributed world, and we'll hopefully have a quick look at how you build web applications in this space, everything's distributed. You're having to haul data back and forwards and hide that away from the user and make it look simple. And you're having to then also, if we flip these round, each of these steps, each of these actions, which is drag and drop, does stuff. So when I run it, so with extract data from table, it outputs these chips, and we can go and look into these chips, and we can run some JSON path on them and go and like break those objects apart and query them. So we've got to be able to make it simple enough that a technical analyst can interact with the system, but it's also got to be simple enough that we can just quite easily get on with this stuff. And I've not got to go on to, well, I go on ChatGPT and ask it how to code, right? But I would do nowadays. But, you know, I can just start to choose objects and filter objects out here. The other concept in here is that we're not purist. So we've got visual programming for being able to build simple flows, and we could drop this line out and add in another activity and do whatever we like and parallel activities. When we come in here, we're looking more at a structured top-down flow. We can put if statements, we can group things, we can do that. But generally, we're looking at some sort of top-down structure. And then when we come to process data, we've then got another area in here where we can then build a data pipeline. So if we give that a little run, we can come in, and then when we want to process data, we can process that as a data pipeline, and we can, you know, get and this is why I'd like a live audience, because I can't hear the heckling of the slight demon that just popped out there on our screen. But we can start to build data pipelines here, and we can do analysis and take the means and pull out values. And actually, what I did here is just simply pull the data, and we can kind of pull out, clean this data up so we can use it later. So being able to build these big data pipelines. So we've kind of got execution engines. The point of this is we've got execution engines all over the place. We've got one here that runs the workflow, and this runs distributed, so it can control an agent in Germany, it can control one at the same time in Mexico, it can pull data together geographically. When it sends data to these agents, or bots as you might call them, they can then carry out instructions here. And so that's running. And then when it comes to do things like data analytics, it's processing that as a pipeline. So it's kind of an execution engine. This data process actually is a topic in itself. And those that are interested, it's my CTO, James Swash, would absolutely bite your hand off to talk to you about it. And so do follow up afterwards if you're interested. So I wanted to show you this partly because I was going to bore you to death by showing you different boxes on screen. I'll just jump back to the screen and we'll come back to Toker in a minute. What we've done is we've created something that's pulled data from Hargreaves Lansdown. What we do, a bit of screen scraping. We've actually then loaded that. So if we come back to our main home screen here with our project, we've built our activity, which is our building block, our workflows, visual programming. Actually, we've thrown some data into this don't care database. I've called it clean data. And we've got that data sitting here. We can pull that down as a CSV or whatever we like. And so these concepts are, it's just quick. It's quick to be able to extract data. And that's the key thing here with all of the low code systems, the same with our competition. So back to the deck ever so quickly. Will that go back onto the screen? I went, yes, it did. So we've had a quick look at automation. We've actually just touched on RPA. Great. We haven't looked at apps yet. We will do. Data storage. We just had a look at how do you store just regular data. The pressure that then starts to come from customers. So our customers are not building screen scraping stuff. They're the NHS and they're doing clinical, the administrative flows and allowing clinical consultants to be able to make decisions quickly and being able to extract data from your patient record systems and national systems that store your data. So quite advanced stuff that has to be highly available, but it's the same concept. I stopped myself earlier when we touched on this in-page logic, which we'll go and have a look at in a sec. So we've got these different execution engines. We're trying to orchestrate flow and we're trying to make it low code, which means actually just make it really usable so we can build applications really quick. And so the system starts to transform. So it's distributed. We've got these different things all over the place. We need to be able to adapt. And as different customers want different interfaces, we need to be able to either allow them to extend it or we extend it. We've then got these other concepts of being able to build execution and be able to do that in a very visual manner, and that's what we explain here. So we'll go and have a look at in-page logic in a sec when we look at apps. The only other thing of note is most recently, and within about the last year and a half, we've then felt pressure because we started to add sophistication to the apps up here that customers actually need relational database and relational data handling. So the word of the day for the word of probably 15 years ago for developers is ORM, object relational mapping, and being able to take code objects and really automatically map those into your database. You're not having to design your database effectively all the time, and there's a high degree of automation there. The problem we've got is because the system's low code and it's dynamic and it's all over the place, we need to put a big D on the middle of ORM and make it dynamic. And what we found is the ORM entity framework, whatever the derivative of Hibernate and all of those platforms that we've used in the past don't work very well dynamically. And that means your models can be changing all the time. So if we, again, just jump out of this episode quickly, when we go to our don't care database, yes, we can interact with SQL databases. That's absolutely fine. But when you want to start adding tables in here, and I just add a test table, and we might want to start to, actually, it's not a very interesting table, and we might actually want to start then connecting these tables together and building one-to-one, one-to-many relationships. That's kind of fine. So maybe does that just compile that now and then it's never touched? But what our customers do is go, well, I've connected this in, and rightly so, because they're designing on the fly sometimes, and I actually now want to go back and change it. But there's no compilation step to go and update all those models and to kind of clear it all down. So what we then also have to do behind the scenes is run around and be able to handle those updates and those changes and those new links. And this gets really complicated when you've got views that are many to many, one-to-one, or, and you've got lots of different things connected. And we've got to play catch up with that. The other thing that you find is the customer will do what they want with your platform. And so you've got to try and think of all the different ways and which ways that they might use it to stay that one step ahead and make sure it's reliable. This has been probably the hardest part of the system, in just as if we looked at an individual feature to get right and to get it reliable, which we are there today. Again, there's probably a whole topic on ORM, and actually there'll be people on the call that have got some really good ideas on that stuff as well. I'm not sure I want to hear them because arguably we fixed it now, and it would be quite depressing if people had a very, very simple approach to it. But it would be extremely exciting at the same time to have a conversation about it. We'll go and wrap up on apps real quick, and we'll knock out an app, and it'll take me about a minute. Showing and versioning comes in nowadays. What we'll do is I will just knock out quickly what applications are where we work. We'll cap off apps, and then we'll hand that over to questions if that's okay for everybody. Obviously, I've packed a little bit too much in here for our talk today. So if we were to just make this analogous. Apps is your front end, automation and the API part of our system is your back end, and then you've got your data. And then because we're not purists, we allow you to also talk if you've got Azure DB or whatever, or MySQL, and you want to talk to those systems, yes, you can do that. And so we've got it in our box, if you like, and you want to stay there, and you do usually for your first prototypes. Then as you start to scale out, you can do that with these type of systems. Examples, right? So we don't do screen scraping per se, and what I've probably shown you quite quickly today. What we do is quite large, complex business applications. They're not just forms, they're entering data and loading it into a database. It'll always be multi parts within that business process. Healthcare, and I honestly said I would never sell to the NHS at the beginning of our journey because the NHS is so complicated. They saw us, and there was I guess an early adopter within a local hospital that brought us in. And we've now worked with the NHS for 5 years, and it's the most rewarding work we can do. And that's not me just being sentimental about it. It is fantastically exciting because a trust, a hospital, is a medium-sized business. They've got loads of legacy, they're complex. There's usually quite small teams. Cost is an issue always. They move quick. And when you do something right, it affects 500,000 citizens or whatever within that area. So it's really, really exciting. So those on the call that work in the NHS or with the NHS will know exactly what I'm talking about. The thing that we do, the biggest thing that we do is referral management. So that's being able to connect GP referrals that come into a secondary, into a hospital, acute in general is where we work, and be able to give clinicians a single view of a patient and pull in data from sort of NHS England APIs and the local e-patient record platforms, typically Cerner nowadays, and link all of these different systems together and just give the clinician a single view so they can make a decision on the referral that's coming in. And if they don't have enough information, they can defer the referral or they can push it to another clinician. As it is today, most hospitals cannot do that, and they don't do it in a sophisticated manner. And so clinicians are spending, I think the number might be 20 minutes or 30 minutes per referral. And they've got a lot coming in. We know about the backlogs after COVID, but just generally, the hospitals are on the back foot. It's in the papers, and making the referral management really efficient is really important to them. Legacy integration is really important. Sometimes we do have to control GUIs. It's something like 1% or 2% of the time, but it's a blocker if you can't do it. And it's all about data integration. Third sector, Prostate Cancer UK. The guy to call out is Gerardo Del, and I will mess up his last name. So anybody with who's Italian on the call will probably win, but Guercel, and he is an MBE. He's a fantastic guy. He took our platform, and he was a tough customer in the early days. He's still a tough customer for us, but he pushes the system very hard. And what he wanted to do is connect data, and I've put a reference actually in here. He wanted to connect data, so when people are raising money for Prostate Cancer UK, engaging with Prostate Cancer UK, they're not just being lost, they're just putting their money in and then forgotten about, and he wanted to connect all that data together, and he did it, and he built it on our platform, and he trained up an internal team, and he was from, I think, originally the Foreign Commonwealth Office. He worked there previously, so he worked with big governmental systems, and he's extremely rewarding and absolute brilliant customer of ours, and that's why I wanted to bring them in today. And finally, the other area that's kind of key, equally as exciting, even though we're talking accounting, and the accountants on the call, I hope, laugh. So onboarding, offboarding of customers. As much as in referral management, that takes up all the clinicians' time, and they're trying to, well, clinicians are trying to run operations and all of that other stuff. Onboarding, offboarding with a lot of the accounting firms are using their most expensive fee earning resources to just onboard a customer. They've also got regulatory commitments that they need to adhere to on that stuff. And part of the reason that holds them up is they've got multiple different systems. They might have Salesforce. In accounting, they might have a thing called CCH, which is the prolific practice management platform. They can't join it all together. And there are lots of other onboarding, offboarding, specific focused applications out there that can help them. But usually it's not just about onboarding and offboarding. There's a whole load of other things that they want to do. And they also want to get that kind of competitive advantage. So I've called out Assets here because they're one of our largest customers, but I can tell you there's a whole wave behind them who are all jumping on using, who we're talking to particularly, and I should think some of our competition are talking to at the same time, is to be able to give them a competitive advantage and connect all their systems together. So you're building forms, it's all web-based, you're connecting things like Salesforce, you're connecting into message API platforms like Boomi, Del Boomi, and MuleSoft, and bringing all that stuff together. So it's all big stuff. It's not just a bit of web scraping, but I'm hoping the stuff that we showed earlier just gives you the concept. Last piece is we've overrun. Simon, you may have to just jump in and say we'll wrap it up. But if you give me 1 minute as you say that, this is the final part of the system, which is an app. Good. And that's it. This is the drag and drop. This is the stuff we saw before. We can preview, we can hide tables. This is pulling the data from the back end, and we're dealing with all the different objects. We can then pull in workflows here in this screen as well. So again, we've got execution engines that are working within the browser. Our competition, a number of our competition, the API, the app building competition, are all doing this as well, or some of them. And you can, connect things together. Bit of a quick rush to the end of our demo. And so in total, I think there's about 4 different execution engines within the environment pulling everything together. That's Toka, and obviously this is recognizable from 1986. We've got the different components we can bring in. I think the final thing just to close off with is, look, if we could go back and somehow bring Mr. Pascal back to the future day, not only can we give him a calculator, we can give him a platform that can build as many calculators as he wants and hand them out to all of his team as a big distributed calculator. I'm sure he'd be quite excited about it. But I've got the references. We can send stuff out later for people if they're interested in following up. And thank you very much.
Well, thank you very much, Matt, for that fascinating talk and an insight into the history as well as what's possible now. Seeing quite a few reactions of applause from the on the screen at the moment. I'll add mine in a minute. Matt, can you see the Q&A, and do you want me to read the questions out, or are you happy to go into the interface and direct?
I can see a couple of old friends in the Q&A as well.
All right.
I've had very deep conversations with. Yeah. So I'll pick Joanna Lopez here, and in my opinion, what's made FileMaker so successful, long living. I'll give you an answer as my thought. There was a guy, Professor Patrick Winston, who gave a talk on AI, and he at the same time as this talk I was watching, talked about the successful companies that came out of the 1980s from an AI point of view. And he said that the companies that tried to replace people and humans effectively, or were too radical, all failed. That was his view. I was too young to know. But the ones that actually looked at supporting businesses and supporting the real problem, if you remember the slides I was talking about earlier on, that interaction of how a market puts pressure on those technology firms. It's those technology firms that listen to the market and respond and react and go along with that dance. It's those that survive. And my argument is that's probably why FileMaker survived. It was tuned to a need. They made the product right. They probably held on in there as well throughout the sort of the late 80s into the early 90s, and they really did cut a niche. Our partner in Canada is also a partner of FileMaker. They're not really competitive to us. They do similar things, but they sort of there's a longer answer as to why we're not really massively competitive, but with similar products. It's a bit waffly. I don't know. Maybe they were also lucky, but it is a great product, and so I'd hope it's down to that. We've got well, I'm assuming this is James Cochrane. So and Joanne, I'm hoping I can find out if that doesn't answer your question, and then you can just chip in another one. So James, we took years doing a firearms licensing system in Scotland, as every area required something different. Yes, so you may have been able to shorten the requirements process. So that's the story within the NHS too, and all the NHS trusts and the IT folk that you speak to there will talk about the difference being an issue. And obviously in the early 2000s, National Programme for IT, some have commented that, everywhere they went into every different trust, there was a different set of requirements, and it was quite hard to, you're kind of herding all these different opinions together. But if you can make the difference normal, so you can build a core, it's being utopian, but can you build a core system that's got the core capability, which arguably out of the National Programme for IT, we do have, we've got a spine. And then the variation that's needed in each trust, can you just make that normal? Can you make variation easy? And actually that's where low code comes in. So there's an argument that, low code could help in that area. The second question from James is, how does it relate to our orientated programming methods of coding, like aspect orientated or data orientated programming? How does it? I could stretch that and say it does. You're promoting reuse and simplifying your program. Some of low code is more akin to configuration. I'm not sure I can give you a fantastic answer. I think it'd go as far as really just that breaking out your program. And when you start on something that's complex, then you start with a bit of software. And I joke that I thought Toka would be a lot easier. I mean, I joke, I genuinely thought it and hoped it would be a lot easier than it was. You at the outset of any programming, if you start wrong, you're going to be in a world of pain later on. And so the thing I've always taken out of things like OOP is it's a strategy for allowing you to survive later on within your journey. If you're building something that's a relative complexity and you need to maintain it and survive, I think low code does that, but whether it does it in similar concepts, I'm struggling to sort of answer that. So I'll look to see if you fire in another question and put me under the pressure a bit more on that.
Matt,
Amy
could I
Dover?
suggest that you stop sharing your screen and you come up to a bigger window, unless you're going to go back to it. Yeah, that's better.
No, there we go. I've got Amy here. So Amy Dover, within low-code platforms, what are the most common ratios of visual programming, GUI work, data pipelines, etc.? Would you say the common ratios are effective enough, or could adjusted ratios work better differently? We landed on our recipe, our ratio randomly. And say randomly, we put a proposal to the market, and did the market like it, and does it take it up? There are some systems out there. There's an RPA platform which is very visual, and from what I can see, in my opinion, is it's really complex. You end up with spaghetti code, and I think that's what dictates the ratio. What we've worked carefully on is where we use visual programming, you're probably not putting more than 20 or 30 nodes or whatever it is on screen. So you're not getting this spaghetti code. And then going back to probably James's last question, you're breaking out individual reusable components that you can pull together and put them into that higher level, that visual programming flow. I think that's the way to look at it. Whatever that ratio is, I don't know. And maybe that's buyer's choice then. We've got Martin Croft. Hopefully I've not missed anybody out there. So can you give us an idea of the processing time that clients have reduced and developed time needed with Toka? Right, so I need to pay Martin. That's a good question. That's Martin's not on our books, by the way. Now, we've done calculations, and every customer is different. You'll see on our website we say around 20 to 30 times. It is about right. It's about 20 to 30 times quicker. There is another percentage in there which we think. So I used to work for a large systems integrator who were brilliant, and I worked on lots of home office and high code projects in the past. And so if I look at some of those projects and the ones we're delivering today, I think we deliver with about 10 times less people as well, which is good because there's less interaction, less conversations, less, you don't need such sophisticated organizations. So there are compromises to using low code, but that comes down to each individual sort of instance. John Lines has hit on the politics. I thought we weren't going to do politics and religion, but we've got the Post Office Horizon issues. So in light of Post Office Horizon issues, how does low code interact with the need or the auditability and accountability? Yeah, okay. So obviously Post Office, that's actually genuinely upsetting. Over the last few weeks, I remember knowing of Horizon and stuff at the as being a system we might have to integrate to when I was in my previous employment and stuff. So I don't know if that was why it was, personally upsetting. But look, if we look at auditability and accountability within our platform, we've built a thing called a pipeline, which audits and logs and tracks everything down to the time. You can adjust that tracking. By default, it's on max. And it will track everything you need. When we design systems as well within the NHS, so if we're doing something like cancer pathways, the skill of our guys, so they're using no code, but they're still the same enterprise and developer mindset and skill to be able to then make sure that we track every record, because you cannot fail. And so that auditability is needed. When you look into accounting, they've got regulatory requirements put on them by the ICAEW, which they have to comply with, which actually generates a need for us to go in. And so correctly auditing, tracking data, it's fiercely important. So if we were to build a similar system on our platform, of course we'd do it different. But I actually don't know what the issues are behind the scenes with Horizon, which would be, I think all of us would love to know as technologists what actually happened there, outside of the people. Okay, so we've got Guillaume here. How is it that something as core as the NHS business as a referral seems like it's not offered as a core functionality by the software? That would have been core of the blob. Yeah, the health software. Okay, so yeah, why is referral not got? It is. So almost as of 2023, the NHS have released a thing called e-referral service. They have a centralized platform called Spine. They are moving a bit quicker. I'm not the expert on this, but 3 organisations, I believe, are now rolled into NHS England. So that's NHS England, NHSX, and NHSD, and we've seen things move a little bit quicker, or whether it's just taken a long time. They've managed to get these platforms built. The complexity comes is there is no one NHS. For us, it's 158 different secondary acute and general hospitals in England that we're interacting with at the moment. They're individual companies and they have on-prem platforms. So they've not pushed everything into the cloud for obvious reasons around security typically. And so having one common platform integrated into all of these different trusts, it's a mammoth task and they haven't done it, which then means you have data really strewn all between the hospital and on central systems. And as far as I understand, and I was a touch young, the National Programme for IT was meant to be that. It was meant to pull everything together. I'm not the authority on being able to comment on this stuff. Our platform will do that. It will start to bring all this data together. It will enhance their ARS platforms. And we're looking at it from the clinician's point of view. How do we actually make it so they can make a decision quicker and simpler? That's our approach. Hopefully that's not too I'm not being a politician. Peter Rook. So years back, I did work on bringing the NHS secondary, where's Peter gone? It's jumped up, user system back into the NHS from BT. Blockchain may eventually be the technology that enables system integration. Possibly, yeah. Blockchain gets floated every now and then. I like to look at it as, I'm an engineer, I like to look at blockchain as just an securely entangled ledger, and could it help the actual integration part? I don't know. The thing with integration actually is the different systems that you have and the way that those different systems are implemented and how that data is structured. In health, they have FHIR and HL7. We've had HL7 for years, which is meant to define how health data and records is structured. But we all know that there's variation and difference, even though there's that underlying standard, and that then causes problems in integration. So it's possible. Time will tell. Anonymous attendee here. Medical records and hospital data have become prime targets for ransom attacks. How secure can programs be made using low code? So when we designed our system, I started in telecoms. I did a little bit around government. We made the system so it could run completely offline and behind air-gapped premises. We did that, and hospitals typically hold a lot of our personal data on their networks, and they obviously take that very seriously. Obviously, that if they get a ransom attack, if they get the North Korean attack that they had, that actually got onto their premises and leaked data out or encrypted the systems, that is a huge topic. What I can tell you from the front line is that all the trusts that we interact with, this is almost number one priority. Our first task actually as we went into the NHS was to shut down a system that couldn't run on anything later than Windows Server 2003. And so it was a massive cyber risk. And so they actually used our technology to export what was endoscopy and sigmoidoscopy records and get them loaded onto a new system so they could get that platform torn down. So they take it pretty seriously. But our platform is running on-prem. We don't run it in the cloud. And I've got my opinions on just that march to the cloud and pushing everything in the cloud. You know, how safe is it? And I trust our the security experts in our industry that they make the right decisions there. But it's, there are risks of putting everything onto the internet. So hopefully that's not too waffly again and answers the question. That is, I think, hopefully I've answered all the questions there, Simon.
Could I come in with one at the end, Matt? If you're a young computer scientist and you're looking what is the best way to take your career in the future, what are the skills that you're going to need in the future to make best use of an environment where low code is widely used in applications?
So I think this opens up an area where technical analysts, technical minded people can get involved in actually building systems. And low code allows people who might be a bit closer to the business to get involved and actually to then also interact with developers. And the developers, almost have a bit of a bridge where at the moment you might have developers trying to work with people who are not technical, which can cause all sorts of unexciting problems. So there's opportunities to say to young people that actually there's a more interesting area within this kind of low code space and being able to build platforms quickly. As an engineer, I do believe still learn your discipline. I'm not pro citizen developer, and I'm not really very pro no code, not in big business. And I know some big businesses have got a double down on that. So I'll set my stall out. And the reason for that is you're not going to build cancer pathway platforms with people who kind of roughly get the process but they don't understand technology. You might end up with platforms that aren't properly auditing and tracking or not appreciating that making changes on the fly could actually impact an end user, for instance. And so having that discipline and that understanding of computer systems is needed. So they should spend their time, learning the art and the discipline, and then things like release and testing and all of these standards. Was it ISO 29119 or whatever? And all of those sort of standards are all still completely relevant in this space. How do you govern it all? How do you bring it all together? It's just what I'm trying to capture today is this is nothing new. This is a continuum. The governance and all the processes are the same, and it's just technology allows you to move a bit quicker.
Well, thank you very much, Matt. It's been we're after time. I think it's been a fascinating talk. Very much, we're grateful to you for coming along tonight and giving us the insights and the benefit of your expertise. You'll see that there are a lot of applause and thumbs up and so on, and even
thank you.
A sort of pop a rocket coming up there.
Great.
Thank you very much. It's very difficult at the end of a talk that's remote to do the applause, but this looks as if it's working quite well. So thank you.
Great. I think that must be the automation I put in place earlier. So that's fantastic. But no, thank you all, and thank you for inviting me. It's been a pleasure.